Hi, so in this video, I'm going to show you how to perform integration with standard functions. So what I mean by standard is, in the A-level formula booklet, you get given standard integrations. So if f of x is sec squared of kx, then the integral would be 1 over k tan kx. So you can see you've got all of these standard integrals. But we also have integrals if we work back from differentiation. So the derivative of tan kx is k sec squared kx, but that also means that the integral of this will be tan kx. Throughout the video, we're going to use these standard integrals to work out various problems. Okay, so we'll begin with question A. So we're going to integrate sec squared x with respect to x. So you can see we have a standard integral. The integral of sec squared kx is 1 over k tan kx. And in this case, the k value is 1 because we just have 1 here, 1x. So this will be 1 over k, which is 1, tan kx, or just x, plus the constant c. Okay, so this is our first integral. So for question B, we have the integral of cosec 3x with respect to x. So now we're going to use this standard integral when this will go from here to this function. And we can see that k in this case is equal to 3. So this k here is this 3 here. So this will be minus 1 over k, 1 over 3, multiplied by the natural log of the magnitude of cosec kx, so 3x, plus cot of 3x. And we have the magnitude here because this function with a natural log can never be negative. Okay? As we progress through this unit, we'll use the reverse chain rule to derive this standard integral from this. Okay, so for question C, the integral of tan 2x integrated with respect to x. So now we're going to use this integral. So this will be 1 over k, or k equals 2. So 1 over 2 ln natural log of a magnitude of sec 2x plus c. And I should have plus c on the second one as well. Okay? So this is a simple introduction on how you use standard integrals. So let's move on to question 2. Okay, so in example 2, we've been asked to integrate the following with respect to x. So the first one is the integral of sec squared x plus 4 over x plus 3 over x squared, all integrated with respect to x. So the first thing I'm going to do is I'm going to split this up into 3 separate integrals. We'll have this as the first one. We'll have 4 over x as our second one, and 3 over x squared as our third integral. And I can write each of them separately. So we'll have the integral of sec squared x with respect to x. And to work this out, we can use this standard integral here, where k is 1. So this will just be tan of x plus the constant c. And then we've got the integral of 4 over x with respect to x. And I can rewrite this integral by taking a 4 to the other side of the sign. So this becomes 4 times the integral of 1 over x dx. And the integral of 1 over x is not provided in our formulas, but this is the natural log of x. So 4 times the natural log of a magnitude of x plus c. And then for the third part, we have the integral of 3 over x squared with respect to x. And just like we did here with the 4, we can move a 3 in front of the integral sign. And we can have this x squared as x to the minus 2. So now we can integrate this by adding 1 to the power. So we have 3 times x to the minus 1, and then divided by the new power. And we can simplify this by having that negative 1 with a 3. So this becomes minus 3, and we can convert this back to a fraction over x. So our final integral becomes tan x plus 4 natural log of x minus 3 over x plus our constant c. Okay? So do you want to try and work out the integral for question B? You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So you can see that I've broken them up into 3 separate integrals. So we'll do the 4e to the x first. We'll move a 4 in front of the integral sign. And when we integrate e to the x, we get e to the x. So this will be 4e to the x plus c. And then for our blue one, again, we can move a 3 in front of our integral sign. So 3 times the integral of cos x. Now, we don't have the standard integral of cos x, but what we should know is that the derivative of sin x is equal to cos x. So when we go back the other way, when we integrate cos x, we get sin x. So this will be 3 sin x plus c. And then for our last part, we have minus 1 over x. We can move a negative out in front of the integral. And like we saw a minute ago, the integral of 1 over x is the natural log of x. So minus the natural log of x plus c. So our final solution is we can add these together, and we get 4e to the x plus 3 sin x minus the natural log of a magnitude of x plus the constant c. Okay? Let's try one final question. Okay, so in example 3, this is an exam style question, and we need to use the integrals both from the integration and the differentiation by working backwards. So the first thing we'll do is we'll try and simplify this fraction. So we can break this up into the integral of 1 over sine squared x plus cos x over sine squared x. We know that this is the same as the integral of cosec squared x. I'll put a little box around the next part, and I'll work this out separately over here. So cos x over sine squared x is the same as 1 over sine x multiplied by cos x over sine x. 1 over sine x is the same as cosec x, and cos x over sine x is the same as cot x. So now we'll add this integral back into our question, and it's the integral of cosec x cot x. So now we'll move on to this one, which is 2 plus x over x squared, and we can break this up into 2 over x squared plus x over x squared. And writing with powers, 2x to the minus 2 plus x to the minus 1. And this will be our third integral. So 2x to the minus 2 plus x to the minus 1. Okay, so we've got our 3 steps. So now we want the integral of cosec squared x. And you can see this does not appear on our standard integrals, but it does appear here. So the integral of cosec squared kx will be cot kx. And in this case, k is 1. So we can say this is equal to cot x plus c. And then cosec x cot x, again, doesn't appear in this list, but it does appear here. And this integral is cosec kx. Again, k is 1. So cosec x. And for our final one, we can move a 2 to the front of the brackets. We'll add 1 to the power and divide by the new power. So this becomes minus 2x to the minus 1. And x to the negative 1 is 1 over x, which is a standard integral of ln of x, or the natural log of x. So finally, we can put all of these together, and the integral will be cot x plus cosec x minus 2 over x plus the natural log of the magnitude of x plus the final constant c. Okay? Well, thank you for watching. I hope you found that useful. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.